Alright, I thought I'd do a little bit of a test here with Google Earth Pro to see how accurate the lat long measurements are. So I set a set pointer on my house. We'll zoom in on it here. And it's a spot on my front sidewalk. And if I go to the current 2021 last satellite view, and I think as far down as I can, if you look down on the corner here, that's about as tight as you're going to be able to go, I think, before it moves out of that, goes into the ground mode. Okay, so what I did is I put a marker right on a crease or a crack that's in my sidewalk, and I placed the marker as close to the edge of the grass and the seam in the sidewalk, and then I wanted to compare the measurement of that to what I am getting on my handheld GPS. Now there is a way with the handheld GPS to actually do what they call waypoint averaging, where it'll sit there for like up to a minute and take multiple readings, and the idea there is it would end up with homing in on the most accurate representation of that point on Earth using a combination of satellites over time as opposed to instantaneously. So if you look at the bottom down here, this is the reading of wherever the pointer is pointing. So you see I'm at 44 degrees north latitude, 93 west longitude, and then this point, I don't know if it'll show up when I bring it up here. I know these pop-ups don't work, but I can read it out to you. It's 44 degrees, 41 minutes, 42.64 seconds, and the longitude is 93, 18 minutes, 17.68 west longitude. I'll put it up on the screen here. Now we're going to compare it to what I can get on the measurement outside. Now before I go out there, I'm just going to step back through the different years, and you can see that that pointer is not always going to be in the exact spot. So there is some slight differences. You can see it's coming off into the grass area here for the 2020 measurement. Yep, see it's at least a foot off of the sidewalk in that view there. So the point being that the Google Earth imagery has got some variation in it over time. Here it's even farther off from where it is today. So now that it's back on the line there, so it does look like it's got, you have to kind of assume there's at least a foot probably of variability in where these points end up. See, now it's in the one from 2012. It's well into the sidewalk area with that same exact GPS point that I placed on the original map. All right, let's go outside and take a measurement there. All right, it's kind of a lousy day, starting to rain a little bit, but this is the crack in my sidewalk, and I got the GPS here with, let's have the antenna right equal with the grass line. And then now what I'm waiting on, since I just turned it on, you can see the accuracies coming down. So we'll wait till it gets down to the 6 foot level. There we go. So now what I'm going to do is go to the menu, waypoint averager, enter, create a waypoint, enter. See the sampling confidence.
at 2%. So we're going to wait until it goes all the way up to 100%. You can see how long it's been going, 20 seconds here. So what it's doing is this number in the corner here is going to get refined over time, and then we'll compare that number at the very end here to what we found on Google Earth Pro. Alright, it's at 84%. Alright, 100%. So now I'm going to hit save and done. So now we got that marked.
Alright, so I put a little spreadsheet together here, kind of comparing the information that we measured here. If we look at that Google Earth Pro using the August 2021 imagery, the pin that I placed as best I could on the corner of the sidewalk and the turf, this was the latitude and longitude values of that pin. Then we went out and we did some measuring using this average waypoint aspect of the Garmin GPS map 65S. And if you look, as I was starting the averaging process, the reading was as shown here for both the latitude and longitude, and you can tell that interesting that we were pretty close on the latitude from what we did with the Google Earth Pro, but the longitude was off quite a bit. Now after we did the averaging, which took 96 seconds before it got 100% confidence, we had a slight change on the latitude, slight change on the longitude. So I'm tending to believe that this line right here is the most reliable value for that location. And I did some calculations, and if we look for every 1/100th of a second on the latitude at my location, it's a little over a foot. So each time we have a change, it's about a 1 foot difference on this second point here. For the longitude, it's 0.72 of a foot for every 0.01 difference here. So if we look at a couple different things after this averaging, the refinement that we did by doing the averaging, we actually changed the latitude from 3 feet and the longitude by about 1.5 feet from where it was initially. So that somewhat tells you that if you really are wanting to get the most accurate representation of a particular point, you really ought to run this averaging function on that Garmin. That's something I didn't do in the cemetery, and most likely that's the reason that was off as much as I was from what the graphics showed. And then I also just did a comparison of what this averaged position here was compared to the imagery where I put the pin on Google Earth Pro, and we ended up with basically the same position, 3 foot difference, but the longitude was quite a bit off. So as I mentioned, I'm more likely to trust the Garmin averaged measurement, which is using instrumentation, as opposed to using the graphic that's associated with Google Earth Pro specifically. And as I demonstrated using the imagery from prior years, you can get some variation there, maybe up to 3 feet. So there's obviously more room for error when they're overlaying that imagery on the data that they have with the satellite. So anyway, I thought it was an interesting exercise. The takeaway is I'm going to use this averaging function now for getting the most accurate representation of any particular point that I'm at. All right, stay tuned for more parts. Thanks for watching.